So we're going to hone our linear graphing skills by taking a look at a second example. So here let's take a look at the amount of snow that is found on Mount Ski. So we're measuring from the 1st of January onwards. So at the very beginning of January there's 250 centimeters of snow. By the time the end of January, which is January 30th, there's 310 centimeters. So obviously it's been snowing a bit on Mount Ski. Now what does a graph of that look like? First step is to analyze what goes on the x-axis and what goes on the y-axis. So the days control the amount of snow. Or the amount of snow depends on the day that in the month. That means that days go on the horizontal and height again on the vertical. Notice I'm including units for both of the axes labels. So there are 30 days, but I only have 20 squares. What to do? Same graph as before. So I've got 20 squares, but I've got 30 days. So let's try that trick that I showed you in the last example. I take 30 days that I want, and I've got 20 squares. And if I divide 30 by 20, I get 1.5. So I could go up in 1.5s, but that's a bit awkward. So I'm going to go up in something that's a bit more convenient, so up in 2s. So 0, 2, 4, 6, 8, 10. Now I'm not going to keep writing all the numbers out. It just gets too crowded down here, so I'm just going to skip. That's 12, 14, 16, 18, 20. And then another 22, 24, 26, 28, 30. And I'm missing this last little bit, so that's going to be a little bit of white space, but that's not bad. I've stretched out my horizontal axis as far as I could. Now the height in centimeters, let's try that. I'm going from a maximum of 310, and I have 20 squares to do it. So 310 divided by 20 is 15.5, and if I round that up to the nearest convenient number, I'm going to use 20. So using going up in 20s from 0, 20, 40, 60, 80, 100. And now I'm going to just jump a couple and put the labels on only a couple of them. So 120, 140, 60, 80, 200. 220, 40, 60, 80, 300. 20, 40, 60, 80, 400. And we know we're not going to go all the way up to 400. We're only going up to 310. That's okay. Now let's plot the points. And I'll plot those in orange. At 0, it's 250. So at 0, it's all the way up at 250. So 200, 200, 220, 240, 260. So 250 is right in between. At 10 days in the 10th day in January, it's 270. So I'm going up from 10 all the way up to 270. That's right there. 20th day, it's up to 290. And at 30 days, it's 310. And now I'm going to connect the points. There we go. So what does this graph tell us? Well, it tells us there is a slight increase in the amount of snow. In January. Could we use that to predict what's going to happen in February? Well, if we extend the line, we could expect that in February, which would be here, this would be February 2nd, 4th, 6th, 8th, 10th, by sort of the middle of the first, after the week and a half into February, it has reached approximately 340 centimeters. This is called extrapolation. Now, what am I assuming in that? I'm assuming that the trend is going to continue. That the snowfall is going to be consistent, that there's not going to be any change. But as we know with weather, there could be a warming trend and it could actually start to rain and it could go down. So when we extrapolate, we are making assumptions, and those assumptions have to be declared. So when you are asked about extrapolation, please explain your assumptions as well. Notice in this graph there is quite a bit of white space. There's all this space that is unused. And the same thing with this chunk up top. So what would the graph look like if we changed the scale? And that's what we're going to look at in our third example.